Let me put this definition up. I'll give you a moment to read it. So we have a formula, and the change in boiling point is proportional to the molal concentration. So let's go ahead and diagram out what the pieces are, and then I'm going to change this formula in just a minute. So delta T sub B. You've got a boiling point of the solvent, and then we're looking at solutions. What's the new boiling point of this solution? So this formula will let us calculate the change in the boiling point. It will not let us calculate the new boiling point, its change. And then the lowercase m is what we used before. It's the molality, the molal concentration. Let's go back and look at the formula. Now, writing it this way, delta T is proportional to the concentration. It tells us that as the concentration goes up, the change in the boiling point increases. But it doesn't tell us how to calculate the change in the boiling point. So in math, if you want to take the proportional symbol out, you have to put in a constant of proportionality. And that's that K sub B. And the value for K sub B is unique for the solvent. It's not unique to the solute. So if we're using water, water will have a value for Kb regardless of what you put into water or whatever else your solvent is. And we're making a solution, an aqueous solution of ethylene glycol. It's commonly put into automobile radiators, and we'll talk about it as a coolant. And we're making a certain concentration, and you're told what the boiling point of pure water is. Now, these two pieces of information, non-volatile, non-electrolyte. The non-volatile simply means we don't have to worry about the solute evaporating. And the non-electrolyte's important because that's all we're dealing with right now. Later on we will have to go back and modify our formulas for electrolytes. But a non-electrolyte means you put ethylene glycol in water and you have ethylene glycol. We're assuming it's not dissociating to any large degree into other particles. Now, as soon as I see this information, what's the boiling point? Then I think, I need the mathematical formula that relates the change in boiling point to concentration. Now, one thing we need that we were not given in this problem, when you do need it, you have to have the boiling point elevation constant in order to do it. Now take a look at the units. Degree C per molal. It's also written this way. Degree C kilogram per mole. I personally don't care which of the two ways you use it. I recommend that you pick the way that makes it easier for you to do and to understand the problem. In the lowercase m, that's molality. We've seen that before. We've done a number of calculations with that. Now we're told the mass percent, and we know molality needs moles, so we need the molar mass of ethylene glycol. We've calculated molality before, so I'm not going to spend too much time on the molality calculation. So to get the moles of the solute, We take the mass of the solute. Since it's a mass percent solution, I took 100 grams of solution, which means we have 52.0 because of the percent grams of solute. And we divide by the molar mass. So now for the mass of the solvent, if we choose 100 grams and 52 grams becomes the mass of the solute, 48 grams has to be the mass of the solvent. We do need that in kilograms. And we get 17.5 moles per kilogram, or if you'd rather, 17.5 molal, lowercase m. I'm going to take the introductory material away because I've only calculated the concentration, and the goal is to calculate the boiling point. So I just moved stuff up. Alright, so delta T sub B, boiling point change, is Kb. So we bring that down. Degree C per molal. And then you multiply it by the molal concentration. Because of the way I wrote the units, degree C per molal, I'm going to go ahead and use the 17.5 lowercase m for units. And then that's our delta T. Do our unit check. Good. We end up with 8.98 degrees Celsius. Now that's the change. So then I have to add that to the boiling point of the pure solvent, which you were given as 100.00 degrees Celsius. And that's the new boiling point of our solution. It's gone up by 8.98 degrees Celsius.